actually the less violent in terms of their intensity. You might have heard about a one term called weather. So what is weather? Weather is basically weather is basically a state of weather is basically a state of temperature, pressure, moisture, clouds, wind at a given time at a particular place. Okay, so whenever we have these conditions at a particular point of time, we used to say moisture. For example, if temperature is more, we will say we have a hot weather today. If temperature is less, you will say we have a cool weather today. If we have a low pressure, for example, which is correspondence to the hot conditions. If there is a low pressure and if you see the wind, so you will observe that yes, on our region we have a low pressure. Okay, and if we have a stability in atmosphere, if you don't see winds, we have a almost still condition with respect to the wind movement in environment, or let's say in atmosphere. So you can predict that here we have what high pressure, for example. If you see some sort of cloud or condensation, so you can say that we have what some sort of you can expect some sort of rainfall. If we have a moisture in our air, you can say that okay, today's weather is dry. If there is a more moisture in your area at a given point of time, you can say okay, in our area today we have a moist condition, today we have a wet condition, today we have a wet air, for example. Okay, similarly you will have a cloud, similarly you will have a winds. So these are the condition which we use to observe with respect to the given period of time on a specific particular place. So state of all of these will be called as what? Weather. I give you example as well. If we have a cloudy weather, you will say okay, today we have a cloud. I hope you have a clarity that how cloud would going to form with respect to the process. So weather is actually being formed by the location. Similarly, temperature and pressure distribution, altitude is also responsible, wind is responsible, landform features are also responsible for the weather. In desert, you will say that we have a hot weather during the day, during the night we have a cool weather. So it is based on what? Temperature, pressure. At the mountain, you will say that we have a cool condition because of the lapse rate. If you are in the coastal areas, you will say that okay, we have a moist air because of the onshore winds. Clear? Landforms, whatever landforms which we have learned in the geomorphology, I hope you have a clarity. Aeolian landforms, okay, I hope you have a clarity with respect to the sea landforms, karst landforms. I hope you have a clarity with respect to the running water landforms, fluvial landforms. Okay, so whenever we have a landforms, accordingly we will have what? Weather. Clear? So weather occur regularly. Weather means the daily state of all of these. The daily state of all of these. Yes, seasonal state can also be considered, and this weather is more predictable and stable. Basically, we know that during the monsoon we have a heavy rainfall. Simple. Okay, we know during monsoon we have what? Some sort of heavy rainfall. Apart from heavy rainfall, we have a high relative humidity. Apart from a high relative humidity, we have a bright sun. We have a vertical overhead sun in India, roughly. Okay, so that is what more predictable and that is stable. We are prepared to handle the consequences or implication of weather conditions those who exist on a particular area. Contrastingly, with respect to these conditions, or just reversal with respect to these conditions, whenever we have a extreme or abnormal weather event, whenever we have a extreme or abnormal weather events, whenever we have a intense temperature and intense pressure, whenever we'll have a intense temperature and intense pressure. Okay, the intense temperature and intense pressure, if it is there and if they are existing randomly, and if they are forming with respect to the occasional or rare aspect which are less predictable in their occurrence, which are less predictable in their formation, when these extreme or abnormal weather conditions are sudden or rapid in terms of their formation, those conditions will be called as unusual weather phenomena. Unusual weather phenomena. Okay, unusual weather phenomena where you can't expect. Okay, where you can't expect that in which area we could have a high temperature, we could have a excess temperature, we could have a excess pressure, and similarly gusty and violent winds. So reverse to this well developed or well distribution of weather conditions based on all of those previous factors which we have learned as of now, okay, about which I hope you have a clarity that how there is distribution of temperature, pressure, humidity, wind, etc., etc. Okay, so based on that, we have what weather condition. But exceptionally, whenever we have a intense temperature and intense pressure, which is there on a one specific particular area, which is not with respect to the pattern or well observable trend of all of these factors, well observable trend of the distribution of temperature isobars accordingly. So those events will be termed as what? Unusual weather activities. Those are not usual, those are unusual, those are random, those are result of excessive heat, or you can say excessive conditions, those who are exist in atmosphere at a given period of time. So when we have a usual weather condition is a normal, it is stable, while unusual weather conditions means cyclones, means fronts. They are extreme, they are disruptive, and they are less frequent. Weather is more frequent. Okay, we have a clarity. We know that when we have a summer, when we have a monsoon, when we have a winter in India. And yes, we also know that when we have a cyclone, but specifically we don't know. Okay, specifically we don't know that at what time period we can have a cyclone. Okay, even we have a trend that usually in this season, uh, like in India, we used to observe cyclone, but we can't say with respect to the predictable manner, with respect to the formation, like whether the cyclone will form in Bay of Bengal or Arabian Sea, we can't say. Whether it will form near to the coast or away from the coast, to what distance it will be formed, we have no clarity about this. Contrastingly, we have a clarity with respect to the wind distribution. Contrastingly, we have a clarity with respect to the temperature, pressure, cloud formation, relative humidities distribution. We have a well developed understanding of all of these based on whatever we have learned as of now. Okay, but we don't know with respect to these. I mean, we don't have a perfect clarity when it comes to the unusual weather conditions. So cyclones are the example of unusual weather conditions. Clear? All right, let's start with the unusual weather conditions. And in these unusual weather conditions, we used to take account of cyclogenesis, means we have to learn, we have to discuss about cyclone. You will get to know about tropical cyclone and temperate cyclone. They are a bit complex, but not that much complex. If you go step by step, they are more easy to understand. However, if you miss at any particular stage, that might be difficult for you to understand. Okay, so be with me, pay attention. Moving ahead, now we are starting with cyclones. They are the example of unusual weather conditions. Here, my purpose was to tell you that how you can contrastingly differ, or how you can contrastingly distinguish between the weather or unusual weather conditions. Okay, when we have a well demarcated pattern of these with respect to the sun's movement, we don't have a clarity with respect, I mean, we have a clarity, but we don't have a well demarcated distribution of unusual weather phenomena. Okay, moving ahead. Cyclone. Now what is cyclone? Cyclone, the meaning of cyclone is what? You might have seen these kind of spiraling of winds, spiraling of winds. You might have seen that we have a wave, a kind of, you know, this shape which is there. And here what you can say that with respect to this specific or this particular shape, you can expect what? You can expect a well developed structure of cloud which is following a track actually. So we have this kind of circulation in our atmosphere, so that is being called as what? Cyclone. What is this circulation, how it is going to form? Let's have a clarity why we have a spiraling of winds around this particular hole which is observable here. So that is nothing but the eye, cyclones eye actually. Okay, let's see what is cyclone. So cyclone is actually a large low pressure system. When I say low pressure system, I hope you have a clarity low pressure means this will be an area where winds will converge, where winds will converge. Clear? Where winds will converge. And when these winds will converge, cyclone will be known as strong rotating spiraling inwards wind. As we have a low pressure, so these winds will move inward or towards the center, and strong winds and heavy rainfall would be there. Strong winds and heavy rainfall would be there when it comes to the cyclone. And yes, this is what they supposed to be the normal gradient when it comes to the wind, but I hope you know that with respect to the winds there will be a deflection, and if you are in the northern hemisphere there will be a rightward deflection. So this is the normal path. Usually we have these conditions when it comes to the cyclone. Okay. So if you have focus here, we have a which in which specific direction there is a rotation which is actually taking place. The we have a direction in this way, guys. We have a direction in this way. So this is what the anti-clockwise direction. Anti-clockwise direction. So the winds, those who are here, they are actually forming because here we have a low pressure, and these winds are actually moving towards this low pressure system. Okay, moving towards the low pressure system, and winds are converging here. And here you can expect that when the winds are converging in this way, we'll have what motion? It will rotate. Okay, it will rotate like this, and when it will rotate like this, while rotating it will move to the other areas. Focus. Okay, in this way. Here you can see. Here you can see. Here you can see the rotational aspect which are here. So the rotational aspect which are here, they are like this. Okay, the rotational aspect, I hope you can relate. Okay, so in this way, again. Okay, so we have a spiraling of winds in this way. So if we have a existence of that kind of pressure, that will be known as what? Cyclone. That will be known as what? Cyclone. And in cyclone we'll have a strong winds and there will be a heavy rainfall. How and why, you will have a clarity in a while. Now, based on the location, based on the latitudinal conditions, that where we can have a these kind of conditions where this low pressure could form. Okay, where we could have a formation of this low pressure. So based on the latitudinal condition, based on the latitudinal condition with respect to the low pressure, I would say with respect to the low pressure, whenever we have a latitudinal condition, and when the cyclone would emerge or when cyclone would form, you can categorize cyclone in two ways. If we have a formation of this low pressure, if it is near to 5 degree, 20 degree, or let's say last to last 25 degree, or let's say you can say in the tropical region. Tropical region, I hope you have a clarity. Okay, so with respect to the tropic of Cancer to Capricorn, we used to call that region as tropical region. So whenever we have a formation of low pressure system in the way we have just discussed, that will be called as what? Tropical cyclone. So tropical cyclone, the circulating wind, spiraling winds will be there, and if they are forming between 5 to 20 degree or 25 degree latitude in both hemisphere, that will be termed as tropical cyclone. Contrastingly, we have a temperate cyclone. Temperate cyclone are also being known as extratropical, as they are forming with respect to the out of tropical areas, so they are being called as extratropical cyclone. They are also being called as mid latitude cyclone whenever we have a existence of low pressure phenomena at this latitude, or let's say in between 30 to 60 degree latitude. We will have temperate cyclone, mid latitude cyclone, or extra tropical cyclone. Okay, so based on the low pressure conditions when they are existing with respect to the latitudinal variation, we have two set of cyclones. Basically, we have a tropical cyclone and we have what, temperate cyclone. Clear? Let's have a clarity with respect to the tropical cyclone. First of all, guys, tropical cyclone means what? The cyclone which is actually forming in the tropical region. The same cyclone is being known by different names when it comes to the equatorial region. Here you can expect, or here you can see, they are being known as hurricanes in Atlantic and Eastern Pacific Ocean. They are being known as typhoons in Western Pacific Oceans. They are being known as cyclones in Southern uh, Pacific Ocean and Indian Ocean. And yes, they are also being known as Willy Willy as well. Okay, they are also being known as Willy Willy as well. Okay, so cyclone would be formed whenever there is a intense heating. Due to intense heating, what would happen? Due to intense heating, there will be a water vapor. That water vapor will rise similarly, and air will rise. Suppose we have a sea surface. So first of all, the condition is what? That this tropical cyclone used to form on sea surface, water. On water they used to form. So whenever we have a intense heating, so what will happen? First of all, the sea will warm. When sea will warm, what we can say, the water, or let's say water vapor will be there. So here we'll have what? Water vapor first of all, or let's say the nearby air which is there, that nearby air will also become warm. When this nearby air will warm, this nearby air will going to rise. So what we can say, the low pressure will be there. So here we have a rise of two things. Air will rise, and yes, water vapor will also rise. Now tell me, when air will rise, what will happen? And when water vapor will rise, what will happen? When air will rise, it will become cool. And yes, when uh, like air will become cool, its temperature will fall. When its temperature will fall, if we have a moisture, relative humidity will be there. As a result of this, saturation will occur, dew point will be there, condensation will be there, cloud formation will be there, rainfall will be there. I hope you can relate. Okay, so we'll have a low pressure and we'll have a cloud formation. When this low pressure kind of system is formed or developed over a large area, we can say the cyclone is started to form. Cyclone is started to form. Cyclone is actually the complex system of closed isobar. Cyclone is a system of what? Closed isobar. Understand, guys? See, we have a sea surface, and when this sea surface will warm, what will happen? They will be rising. Okay, so we have a rise, and as a result of that, we have what? Cloud formation. We'll have what? Cloud formation. Okay, at various height, you can say. Initially in this stage, as we have a cloud formation, I hope you remember, there will be a latent heat of condensation. When there will be a latent heat of condensation, here the conditions would be what? Here the conditions would be warm. Here the conditions would be warm. And if we have a continuous heating of sea surface, what would happen? The air will rise, the streams of air, the convectional air would rise, and now here the air will not here the air will not get cool, because the air which is here, that air is actually warm. Saturation will not take place. So in order to get cooler, that air have to rise further. Now here this air will going to rise further. As a result of its further rise, what we can say, there will be a condensation, or all those processes which we have learned as of now, saturation, relative humidity and all. So we will have what? This saturation, and as a result of that, cloud formation will take place. Similarly and simultaneously, we will also have a latent heat of latent heat of condensation, which will be there here, for example. And as a result of that, here we'll have what? Warm air. Now the third stream, which is actually coming because of the constant insolation, as a result of that, we'll have what? Another stream of air. Here it will not get cool because we have warm air. Here we also have warm air. In order to get cool, this air would have to travel vertically more, and when this air will have a more vertical travel, we'll have what? Yes, condensation which will going to take place. And again here we'll have what? Here we'll have a warm kind of structure. Now this kind of system, if it will going to form till the height of troposphere, this kind of system will going to form till the height of troposphere, what would happen? So suppose, let's say this is what the height of troposphere. Now beyond this height, there will not be a what? There will not be a condensation or cooling of air. Clear? First thing. So here, as we have a rising air, so what we can say, we have a low pressure. Now it is unusual weather phenomena. You might think that with respect to this low pressure, we might have some sort of high pressure at another area. No, that is a usual weather conditions. Okay, and we are actually discussing about the unusual weather conditions which are not following the general distribution of all of these things which we have learned as of now. So here we have a low pressure, as we have a rising air. So whatever air which is actually rising, the air will going to get cool. So here air will cool, and when air will cool, this same air will going to sink. Okay, same air will going to sink here because it is unusual. Okay, when this air will become cool, or let's say cloud formation will be there, so moisture will be moved out from air. Below we will have what cool air, and that cool air will going to sink here. I mean here, even here in this specific or entire system. So here we'll have what, here we'll have a closed isobar system. Here we'll have what, low pressure. Okay, here we'll have what, low pressure. Correspondence to this low pressure, we would have what, for example, this white one. So we'll have a low pressure here, another low pressure is there. With respect to the low pressure, we would have what, for some extent here, the this white air stream which used to rise, and when it will be cool, will have a cloud formation. So moisture is moved out from atmosphere, air is there, air is cool. Now the same air will going to sink. So here we would have what, correspondence to this, we will have a high pressure, for example. Okay, similarly we would have so many other streams, I mean correspondence to this diagram, and we will have a closed isobar system. And whenever we'll have this closed isobar system, among them this low pressure is what, more intense. As this low pressure is more intense, wind will going to move towards this low pressure, wind will going to move towards this low pressure. And if you are in the northern hemisphere, so winds will going to move anti-clockwise. Okay, in this direction we will have what, the system of cyclonic depressions, or let's say cyclone, which would going to form. And now here the winds are actually moving in this way. These winds are violent because these isobars are closed. Okay, these isobars are closed, so we have a wide or very much random pressure gradient here. So when we have a wide or very much random pressure gradient, so here we'll have a formation of what, here we'll have a formation of this cyclone. Okay, so here we'll have a continuous interaction in this. Will we continue with this particular aspect in next video or in next session?